price your products. Is it subscription-based billing and whatnot? Those are really important. Okay, last thing that I want to talk about this is to introduce the Azure SLAs. So let's just take a breath and let's just step back from what we've been talking about. We've been talking about functional requirements and designing for you and your requirements. Now let's talk about those SLAs and those requirements that Azure communicate to you, the customer. So we communicate those in lots of different ways, but a really important set of documentation that we provide publicly is our service level agreements. So let's jump into a service level agreement here to look at our service level agreements, or SLAs. Now, I often joke that no one likes reading SLAs. That's not really what most people got into engineering to do. However, this is really important stuff, and as part of your R&D, it's essential that you read these SLA documents. Even from other vendors as well, you need to understand what you're agreeing to when you deploy a resource like the Azure SQL database, for example. Right, let's go into a specific example here. This paragraph, the second bullet point down here, is talking about a standard or general purpose or business critical Azure SQL DB, and you can see here that this has an uptime guarantee. So this is not an absolute guarantee, it's a financial guarantee. What we're saying is that we have an availability guarantee of at least 99.99%. Okay, so that's another way of saying that is 4 nines, 99.99% or 4 nines. There is an excellent online resource called Uptime Is, where I can plug in that 4 nines number, and it will tell me what does that mean in terms of downtime every month. So for example, this is an excellent uptime value. 4 nines is very good. It's extremely available, and so what this is saying is we should plan for but not expect up to 4 minutes and 22 seconds of downtime in a month. Now, we really hope that you won't have any downtime, but really when you're getting up to this level of availability, you're really talking about very short transient failures in the system. So we are starting to say, well, those failures that we expect you to see are really transient. They're going to be measured in minutes or seconds. And that good example of how we should plan for this. Let's just plug in another figure in here, which is 3 nines or 99.9. This is saying that we should plan for but not expect 43 minutes. So we're starting to get up towards the hour mark every month. And when you're deploying a 3 nines service, or if you have a 3 nines composite SLA, which we'll talk about in the reliability section, then it's important to understand that we're planning for that amount of availability. Let's take 0.5% off that and see what happens now. You can see we've jumped right up. We've gone up to heading towards 4 hours of downtime a month that we now need to plan for, and it's really important that we understand the difference between these numbers, 99.5, 99.9, 99.99 and so on, and that helps us to plan. Right, more about that coming up very soon in the reliability talk as part of this session. But before that, I want to hand over now to John Downs, who's going to talk through some of those cloud fundamentals that we should all know and understand. Thank you, John.
Thank you, Dan. Before we go too much further into cloud architecture specifically, I want to spend some time talking about the history and the economics of the cloud, because understanding this helps to explain why cloud architecture is a little bit different to other types of architecture. Also, architecture is often about making trade-offs between different factors or making decisions to prioritize certain things over others. And it's important to understand the consequences of these trade-offs. So understanding the fundamentals of the cloud is really important when you're trying to make those decisions and trade-offs. So let's start by talking about before the cloud, what happened in olden days before the cloud existed. So traditionally, if we were in a business or in an enterprise of some kind and we needed to run some servers, firstly, we'd have to have a place to put them. So we would either have a corporate server room, which might be in our offices, or it might be a data center that we own ourselves or that we lease a part of or lease server space within. Then we'd have to actually purchase some servers and maybe other infrastructure as well. So things like network infrastructure and racks and cooling and all those kinds of things. All of that equipment would be procured, which usually would take days, weeks, months often. We then have to install it, and then it would be operated for a fixed period of time. And usually that was 3 to 5 years, typically. At that point, the equipment was no longer useful to us or potentially was out of date, and so we decommission it and then go through that whole process again to replace it. Now, because of the way that this whole model works, this required capital expenditure.